Hello BTEC Level 3 Year 2 Engineering students. In this video we're going to look at the FET circuit that's in assignment 1 and see how the thing works, label all the parts and explain the operation of it using the technically correct language. Okay, let's give it a crack, see how we get on. We're going to do this in two parts. So the first part is considering how the circuit, what it's doing now as it sits as we can see it. So we've got a button here that is not made. You can see that there's no connection between that. So that's a push switch that we need to push in order to make those contacts. So we need the proper language around that would be to say, as it's sitting at the moment, the switch is, we could say it's not made, would be one way of describing it. Another way of putting it would be released. So the button is released in its released state. That would be another way of describing it. The button is released, the contacts are not made. Or another way of saying is the switch is open. Any one of those three describe the switch in its current state. So with that open, really we can ignore virtually all of that part of the circuit and just focus on what's happening on this side here. I've labelled another part of the circuit up here, which is the power supply. That's this plus 24 volts and the 0 volts coming down here. Those two lines will go off to the power supply. So we've got a 24 volt supply rail coming along here. We look at that coming down here. We've got a box that's labelled relay. We've got no idea what's in the box. But it must have a very, very large coil of wire that creates a magnetic field, and that will operate a set of contacts somewhere inside the relay. What we don't know is whether those contacts are normally open or normally closed. So instead of talking about the relay being on or off, or the contacts being open or closed, we'll talk about whether current's flowing through the coil or not. And again, the technically correct language for that would be it's energized when current is flowing through it, and it's de-energized when current isn't flowing through it. So we won't worry about whether it's open or closed, made or unmade. We'll just say it's either energized, current flowing through it, or de-energized. We've also got a diode here. Now the diode is connected in such a way that it's not conducting. So diodes only conduct in one direction, and that's in the direction that the arrow points, so that's in that direction. We've got a plus voltage up here, and we've got 0 volts down here, so no current is flowing through the diode. Bit of a mystery why it's there at the moment. Then we come down here, we've got TR1, which is an N-channel FET, so it's a field effect transistor, and it's of the N-channel variety. We can tell by the arrow pointing in that direction. It's got three connections: the gate, the drain, and the source. And an FET is a normally on device, unlike a bipolar junction transistor, easy for you to say, which is a normally off device. A field effect transistor is a normally on device, so current will flow from the drain back to the source. Current flows down the drain and back to the source, which is the power supply. So because the switch is open, there's nothing on the gate at the moment, which means the FET is on. So when the FET is on, it's just as good as having a piece of wire connected from there to there. There's nothing to stop current flowing through the transistor. It's a short circuit effectively. Now that tells us that current then must be flowing from the 24 volt supply through this coil of wire, which is creating a big magnetic field around it. And then it's flowing out through the relay down here, and it's flowing through our transistor, our FET, and back down here and back to the source again. So we've got current flowing through. So with nothing on the gate, we would say that the relay is energized. What we don't know is what's happening with the contacts. So that, I think, is one part of the circuit when we consider that this switch is not made, released or open. what you've got to do now is stay tuned for the next thrilling episode to look at what happens to this circuit when the button is pushed. I'll bet you can't wait.